Hello and welcome to Math 219. Today we are going to be talking about vectors as a subject. So if you have any problems, so we're going to be working on this one particular practice problem. If you have any more problems that you want us to do, feel free to post on the forums and we'll be more than willing to help. So at this time, I'm going to give you a little bit of time to pause the video and try and solve this problem for yourself. And when I come back, I will solve it out and you can compare your work with mine and see if you got the answer right. So yeah. All right. So we're trying to find a vector of magnitude 3 in the direction opposite of this given vector, which is 1/2 I hat minus 1/2 j hat minus 1/2 k hat. So the first thing that we're going to want to do is we're going to try and find a vector, a unit vector, in the direction that we want our final vector to go. So the first thing that we're going to want to do is we're going to want to find a vector, unit vector, in the direction of this vector v. So we're going to first calculate the magnitude of this vector. So really quickly, I did out the magnitude of this vector. If you remember, the formula for calculating the magnitude of a vector is very similar to the distance formula. You just square each individual component of the vector, add them all up, take the square root of that, and that gives you the magnitude of the vector. So now what we're going to do is we're going to use this magnitude in order to come up with a unit vector that's in the same direction as v. And this equation so you take, in order to get a unit vector in the same direction as v, you take your vector v and you divide it by its magnitude. So I'm going to go ahead and do that now. So in order to just save a little bit of space, remember dividing by a fraction is the same thing as multiplying by its reciprocal. So, yep. Okay, so this is the unit vector in the same direction as v. You can express it as square root of 3 over 3 I hat minus square root of 3 over 3 j hat. You know, just simplify this formula a little bit. But for now, I'm just going to go ahead and leave it like that. So what we're going to want to do now, since we don't want a vector in the direction of v, we want a vector in the direction opposite of v, is we're going to go ahead and take this vector and negate it. So just take negative u, and that gives minus or plus. And now that I've negated every single one of the terms, we have a vector that is in the opposite, a unit vector specifically, that is in the opposite direction of our original vector. So now in order to get a vector of magnitude 3, what you have to do is you have to take a unit vector. So this is u in the direction opposite of v. I guess I'll call it u negative v. And you take that vector and you multiply it by the magnitude that you want. So once you have a unit vector, which has a magnitude of 1, that's a very important thing to remember, and you just multiply that vector by 3, and that will give you a vector in that same direction with the magnitude that you want. So if I go ahead and multiply term by term, every single vector, every single component by 3, and this is the final answer. Technically, you can simplify it a little bit more, so I'm just going to go ahead and do that really quick. And this is the final answer for a vector of magnitude 3 in the direction of opposite of our original vector. So yes. So that's the basic idea of how you can create a whole bunch of different vectors with different magnitudes and directions that you want. If you want, you can go ahead and check out the magnitude of this vector. Remember, the equation is as above, the sum of the squared components, and then you take the square root of that. So sum all the squares of the components, square root that, and this gives the magnitude of the vector. And this should work out to 3. And that's the basic idea of how you do this type of problem. So thank you very much for watching. If you have any problems that you want us to do, either in this week's activities or in some future activities, feel free to post on the forums. If you have any more problems for this week, we'll be more than willing to do them. And if you have any particular problems that you want us to do in future weeks, we could even do these on a video or something like that. Do them on these videos or something like that. But yeah, so thank you very much again, and see you in class.